Hello, this video is the solution guide for the Geometry CBA number 2 practice test. In the first problem we are asked to find the area of a composite shape. To find the area of a composite shape, you will have to separate the shapes in the figure, and then find the area of each shape. This shape can be broken up into a rectangle and a trapezoid. Now that the shape is split up, we have to find the area of each shape. The area of a rectangle can be found by multiplying the length of its base by the length of its height. After multiplying the base and the height, we will get that the area of the rectangle is 540. Now, we need to find the area of the trapezoid. To find the area of the trapezoid, you must use the formula 1/2 times base 1 plus base 2 times height. Once you use the formula, you will get that the area of the trapezoid is 202.5. Now that we know the area of both figures, the next thing to do is add the areas of each shape. 540 plus 202.5 is equal to 742.5, meaning that the area of this composite shape is 742.5. In our next problem we will once again find the area of a composite shape. Once again we will break the shape into smaller shapes, and then find the area of each shape. As you can see, this figure can be broken up into a rectangle and a triangle. Now that we know our shapes, we need to determine the length of the dimensions of the two shapes. Notice that the scale is going by threes. If the height of the box has 12 boxes, then the length is 12 times 3, which is 36, and a width of 4 boxes, meaning the width is 12. We can do the same for the triangle, and then find the area of the shapes. To find the area of the rectangle, we will multiply the base times the height. After multiplying the base and the height, we will get that the area of the rectangle is 432. Next we will find the area of the triangle. To find the area of the triangle, you will multiply 1/2, or 0.5, times the base times the height. After multiplying each number, we will get that the area of the triangle is 67.5. Now all that is left is to add the area of each shape. 432 plus 67.5 is equal to 499.5. Problem 3 is another problem on finding the area of a composite figure. Notice that the scale of the coordinate plane is 1. Once again, we will start by breaking down the composite shape into smaller shapes. As you can see, we make a rectangle and a trapezoid. Next we will find the area of the rectangle by multiplying the base and the height. After multiplying 16 and 3, we get that the area of the rectangle is 48. Next we will determine the area of the trapezoid. Recall that the formula for a trapezoid is 1/2 times base 1 plus base 2 times height. Once we use the formula, we get that the area of the trapezoid is 27. The last thing to do is find the total area by adding the area of the rectangle and trapezoid. The total area is 48 plus 27, which equals to 75. Our next problem asks us to find the perimeter of the polygon below. To find the perimeter of a polygon, we must add all of the side lengths. However, we can only determine the value of side lengths going vertically or horizontally. As you can see, the height of the triangle is 27 and the base is 30. To find the diagonal length, we must use the distance formula. To use the distance formula, we must determine the coordinates of the endpoints. Then input the coordinates of the endpoints into the distance formula. You might notice that when we use the distance formula we are actually using the Pythagorean theorem. After using the distance formula, we get that the length of the diagonal side is 40.36. The last thing to do is add the lengths of each side. 27 plus 30 plus 40.36 is equal to 97.36, meaning that the perimeter of the triangle is 97.36. Now we will find the perimeter of a pentagon. Recall that to find the perimeter you must add up all of the side lengths, and that you can only find the lengths of sides that are vertical or horizontal. To find the length of the diagonal we must use the distance formula. First we will determine the coordinates of the endpoints. We can find the distance by using the distance formula or Pythagorean theorem. Here we will find the diagonal distance by determining how far are the points both vertically and horizontally, and applying the Pythagorean theorem. When we simplify the expression we get that the distance or length of the diagonal side is 37.59. The last step to finding the perimeter is to add all the sides. After adding all of the side lengths we get that the perimeter is 130.59. Our next problem asks, what will happen to the perimeter if the dimensions of each side increased by 4? For this kind of problem, it is best to find the perimeter of the original figure, then draw the new figure, and find the perimeter of the new figure. The new figure will be a 8 by 12 rectangle, and they have a perimeter of 40 versus the perimeter of 24 of the original rectangle. This means that the new shape is 16 more than the original shape. The next problem asks, what will happen to the area if the dimensions of the rectangle are doubled? Once again, the best thing to do is find the area of the original rectangle, which is 10, then draw the new rectangle with dimensions 4 and 10, find the area of the new rectangle, which will be 40, and compare it to the original area. 40 is 4 times larger than 10, meaning that the area of the new rectangle is 4 times larger. This problem asks, to find the area of the regular pentagon. To find the area of a regular polygon we will construct a triangle by drawing auxiliary lines from the vertexes to the center. Now all we need to do is find the area of the triangle and multiply it by the number of sides. The area of the triangle is 10, so the area of the pentagon will be 50, because there are 5 triangles in the pentagon. This problem asks, to find the area of the regular hexagon. Once again, we will draw a triangle, find the area of the triangle, and multiply the area by the number of sides. The area of the triangle is 31.5, so the area of the hexagon will be 31.5 times 6, because there are 6 sides or 6 equal triangles inside the hexagon. After multiplying 31.5 by 6, we get that the area of the hexagon is 189. Problem 10 asks, to find the midpoint. To find the midpoint we will use the midpoint formula, which is x1 plus x2 divided by 2 and y1 plus y2 divided by 2. All we have to do is plug the given coordinates to the formula. Once we plug in the numbers, we can input them into Desmos, or make the necessary calculations. After that we will get that the midpoint is 2, 9. In problem 11 we will once again find the midpoint of 2 coordinates. Once again, we will use the midpoint formula, plug in the coordinates, and make the necessary calculations.